Good morning. Good morning. Good morning. Compliment of the season. Welcome back to Jamal Engineering Solution. Welcome back to Jamal Engineering TV. Like, if you followed our previous video, you can see that we are committed to enlightening ourselves, and particularly the upcoming engineer, to impart them with the knowledge we have as a way of contribution to our society also. And then I told you before, one of our major focus is to pass on the knowledge, the experience that we have over the years with the practical project that we have done, practical project we have designed, structural, architectural, M&E, then the one we have done practically as a consultant, and being involved also in the construction, supervising the jobs. These are the live projects that we want to be sharing with you. And quickly, I'm going to be sharing a screen of a building project that we have done in 2021 to 2022. All right. It's usually a pleasure. So just kindly subscribe to Jamal Engineering TV so you can get all the details about our project. So I will share my screen with you now. I'll share the screen with you quickly so that we can go further on that. Don't hesitate. Anytime you have question, you can ask. If you have question, you can ask anytime, so we can give you the details, further details. I'm sharing my screen with you quickly before I go to the software we are using for the design. All right, so a quick one. I told you before, the first thing to do when you have the architectural drawing is to study the concepts of the architect, the idea he has, because I also told you that before architect come up with any plan, all right, any design, you might have gotten a brief what the client is looking for, what the client wants. So as a structural engineer, you may not be able to detect what the architectural drawing will look like. Your own is to study it and make sure that you position your columns and beams and then slab according to the layout of the architect. From here, we have 6 units of terraces altogether. It's about 42, let's say 43 meters long. So we have expansion joint. If you're looking at my screen, from grid 1 to grid 3 is unit 1. From grid 3 to unit 5, grid 5 is unit 2. From grid 5 to grid 7 is unit 3. From 8 to 10, you now have unit 4. From 10 to 12, you have unit 5. From 12 to 14, you now have unit 6. 6 units of terraces in this regards. Now, that is when you are following horizontal. When you are coming along the vertical, you have horizontal, you have grid 1 to 14. Then vertical, you have A to G. And the way I normally do mine is that the way architects grid his own drawing, that is the same way I follow the grid. So when we get to site, you don't have confusion. All right. All right, so let's look at this, the PDF of the building. I will not show you the architectural, but the structural layout is exactly according to what the architectural looks like. So we don't have columns um, hanging around where or position where there is open. No, you enter from where. If you see my cursor here, is an ante room here with the toilets. All right, then you move like this towards this is the sitting room. The family lounge is here. Then when you come here is the dining. Then you access the staircase through this way all to the up. You have your kitchen in this side. Then you have a small store here. All right, a small store here. And then you have the boys' quarter from the back this way, from this way. So that is how the building is like. I will share with us again. I'll share with us again. Um, Let me quickly go to Orion. It's just a matter of choice. The Orion and the Prota structure can exactly do the same thing. Very few things that Prota can do that the Orion cannot do. There are very few. All right. For example, I will show also maybe next time. We can just name this. We can just name this plot 23 Abuja. Plot 23 Abuja is just for identity. Or we can just say zoom 1. All right. Rather, we use project 1 so that we can be going serially. Project 1 is a new project. So let's quickly go. We are in Nigeria, so we either use Eurocode or BS. I just got a book from one of our senior colleagues. All right, the structural about Eurocode. It's just his choice. Some people argue that Eurocode save more material than the BS, but in this project, we have already done it, so let's use the BS. This is my. Let me share this screen again. I have to share the screen so you can see what I'm saying. All right, so you cannot see my screen. All we did is just open a new. In fact, if you still want, you can do this way. Just open a new project. Okay, then do your setting. Right now, we have the cycle here, the rectangle. You can make it a square, but it's a rectangle. Let's look at our grid. All right, this is this icon, axis. You pick the axis. Like I told you, this is A. All right, then you can pick another one, close it and pick another one quickly. I want to see how we can be fast. Let's make this 1. All right, as we have it on the drawing. You can adjust anything you want the way you want it. All right, that is what maybe some people don't know. In this situation, this particular terrace, all right, I will be giving us various type of building. In this particular terrace, we don't have cantilever. We don't have cantilever. I will show maybe it's today or tomorrow, the one that has cantilever. In this case, what we're going to be doing is best to take from unit 1 to 3, where we have expansion joint. Then whatever remains, you can as well mirror it to the other side. Now, this is what we have. What next? Let's just generate our grid first. From 1 to 3, you have 4.362. 4.362. Okay, so you go to your, when you right click, you see offsets. All right, you type 4, 6, I think it's 4.362. All right, can we check it again? 4.362. All right, that is from 1 to 2. From 2 to 3, you have 2725, 2725, 2725. So you have 3. So what next do you have? Is the same thing because it's a terrace. 4.362. You see, when you are working with Orion, it's a bit different from both Orion and the structural software. Is different from when you are working in AutoCAD. All right. If it's AutoCAD, it's something that you can just repeat and continue like that. But Orion, you have to come back to your ASICs offset. Every time you want to do it, you have to come back. So you have 4.362. We're on unit 3 now. All right. 2725. So this is, as I told you before, this is grid 7 now. So what we have, normally at the expansion joint, we have 255. 255 in between the two grids. That is the expansion joint. All right. So you have 25. You have 25 mm, 1 inch in between the beam or the block for the expansion joint. So this is what you have quickly. Then you will come, since we don't want to proceed with the other, this is along the horizontal. Let's look at the vertical quickly. I'm taking my time so you can get every detail you need. All right. So from A to 2A, if you look at it, from A to A2, you have 3 meters. Don't worry, we'll find a way. 3 meters. Type your 3 meters. You come down. Then you have 3.225. That is to C. 3.225. This is to C. So what it means is you may be wondering, I know why it's like this, because this particular building was redesigned. So for us to maintain the old grid, that's why you have A and then A1, all right? Then A to A2. These are the new grids that's been introduced. B, now there's nothing on B. All right, but we want it to be showing. So when you are looking at the old drawing and the new drawing, you know that, okay, this is what it is. Then you move to C. From C, then you now go to D. So let's just be going. You see, from C to D, you now have what we call a 40, 50. As I said, you come back, you say 40, 50. That is the area of the staircase. All right. Then you now come again. From D to E, you have 2, 2, 2, 5. Quickly, 2, 2, 2, 5. If you don't go back to this icon, you won't be able to offset. Then the last grid, you now have 3275, 3275 quickly. So that is what you have. All right. All I need to do now, so that when I get to AutoCAD, I don't struggle too much. I can reduce this by stretching it back. So this is what we have. I told you I will stop here because from whatever you have here, you can take it to the other side quickly. Now, what's the next thing? If you want to, you can quickly just set your general setting. Come to your general setting. Normally, view, save. After 10 minutes, I will be saving. Then I have company, Jamal Engineering Limited, Abuja. That's general. From building, you can go to your building, you have parameter, click your parameter. I've already set the BS code, BS 8110, 1997 UK structural use of concrete. All right, I then have a BS 6399 UK also for loading of buildings, for loading of buildings. All right, so the bearing capacity of the land is 168. All right, the soil tests have been carried out. We have both live and dead load. So G and factor Q is there. The lateral load is that the columns are braced. Then title, as I said, we are using project one, made by Jamal Engineering Limited, checked by Engineer James. The project is, the last project was 102, so we can say 103. Then this one, today is December 28th. So that is that, so that you can trace your record. If you also want to do further setting, go back to your building. You can see your setting. This building is particularly two suspended floor, that is 3 floor. Go to your column now. In this column, we have 230 by 230 all through. 230 by 230 all through. Then go to your center of the column, choose this icon and drop. All right, you can go either way you want. I'm using simple. We don't need to even drop anything on the expansion joint. We don't need it. Well, you drop your columns at the point. It may not that be easy if the building is not simple. All right, but this is simple layouts. So I'm going the way I'm going. I'm going to be doing duplexes also. And other complicated structures as plazas and things like that. Also, there are some terraces that, like I said, that has cantilevers, and most of the architects, they will be repositioning their walls on the first floor or the second floor. So telling you that you cannot um, have the same column that projects from the beginning to the end, as the case may be. So you have to be changing uh, alongside with what the architect is changing. So you can have a point load as the first floor, have a point load the second floor. So in this particular building, there were actually 12 units. So we have 4 contractors. Each of the contractor has 3 units. This one that we're doing now is just one for contractor. And I just remember that we have 46 column for each of the contractors, because I also do the bill before their payment, approve their payment from the company. When you are done with this, your column, don't worry. After you have done everything, you can as well go back to your building and set your, you can set before you generate, or after you generate, you can set, but it's better you set before. What's our headroom? We have 3.6. That is what the architect gave us as our headroom. What is our foundation depth? We use 1.45. All right. That from the blinding to the top, we can as well use 1.5. 1.45 is fine. That was what we use. We assume roof level as a normal story. You apply. Okay. Assuming you have your 3D, it will automatically follow. Then the Orion is, the software is asking you whether you're going to be impose load reduction factor modifier. You say yes, we are going to. The higher you are going, the load will be reducing. Okay. That is why in if you are in Abuja or any cities, the urban development or like the FCDA, the building inspectorate, before they give you approval, for example, your 2 suspended floor, all your ground columns supposed to be Y20. Once you are going above 2 suspended floor like that, there is a requirement that you have to meet. All right. That is what we call standard. From here, I've changed. If you look at our 3D, you'll see that we have already changed the height of the story. But then let's go quickly to beam. This is our beam icon. What's the size of our beam? All our beams are 230. The center is 115. The depth is 450. Just type it. Then come this way. As I told you, you can just, I just want to go this way. You can go horizontal first. So you can now come vertical. You drop your beam. Drop your beam. I want you to have a broader view, detailed understanding of what we are doing. So I'm taking my time. This is Jamal Engineering TV. Subscribe to our channel so you have detail of everything we are doing. We know, I told you, we are serious people, professional to the core. So we don't joke with our projects or with any of our clients. So any opportunity we have is an opportunity to deliver the best in both consultancy and then project execution, project management. So we consider both the safety in engineering, both the safety and the what we call the economy of the project. If your project is safe and it's too costly, then you need to look at the cost of that project. You can see the 3D there. That is how it should look like. So this is what we have. Then go quickly to our slab. This is our slab. You pick the slab. The thickness of our slab is just 150. The concrete cover is 20. The dead load, self weight of the concrete is 3.7. Don't forget, when you are done with general, you move to your load. Okay, general give you the depth of the slab or the height, some people call it, then the concrete cover, then the load. So you now know that in this case, we are dealing with residential house. All right, so when you right click, the software will show you, okay, for residential is 1.5. So in this case, let's leave it as 1.5. You drop your slab, this unit 1, this unit 1. This is a staircase, so you don't drop slab on the staircase. This is unit 2 now. This is unit 3 now. Don't drop slab on the staircase. So this is how this is looking like. You can close. So practically, you can see this is how it should look like. Then quickly, what we should do now, you go to your building, in search building, story, sorry. We're going 3. Ground floor, first floor, second floor. So it's 3. You have 2 suspended, first floor, and then 2, second floor. So when you put 3 story, you mean ground floor, first floor, and third floor. Okay? Okay. So if you come to your 3D, it will show you. Can you see now? So the last floor, which is like the roof level, is acting as a roof load. That is how the software is built. So you go back to story 1. Story 0 is your foundation. Story 1 is your ground floor. Story 2 is your first floor. Story 3. Let me come again. 0, 0 story. 0 is foundation. First floor is your first floor. Second floor, story 2 is your second floor. Story 3 is your roofing. In this case, it's talking about the face that is at the top, like 3.6 above the ground floor, above the natural ground level. That is what we have. So if we are looking at the 3D, once we generate it, you know what I'm saying. When you click here, it will show you there. So when you insert, you go back to your building again, you generate. So you must be on the unit or the story you want to generate to the other before it can work. So from 1, we are going to 2 and 3. So we generate everything. All right. The building I've generated. This is what I'm saying. It is now that you have your beams and column all generated to the roof level. All right. So you can see, if I'm on the 0, you can see there is nothing, but the grid will move down to this. So if I'm on the first, it will come down to this, go up. If I'm on the second, you can see my grid is moving. On the third, you see that the grid is moving. So that is how it is. So you must be on the at the level you want to be working part time. All right. In this case, if one of the things you should not forget is to load your beams with wall. All right. Because there are block works on the residential buildings, most of them has wall. So you don't design less than what a beam is carrying on site. So we use external beam, external wall rather. So you load it, external. Then we have to determine 450 away from 36. So you have 3.15. That is the height of the wall, because already we have beam that is dropping from the slab down. So you can copy this and then select all the beams and drop the load. If you have any question, don't hesitate to reach out to us. Jamal Engineering. Our email is jamal for success@gmail.com. Our number will be displayed very soon on the screen. You can reach out to us, subscribe to our channel. You have every detail and every question you want to find out pertaining to structural design and project management or project execution. All right. There are ample opportunity for you. We are not the best, or we are not the overall, but we are doing our best as construction is concerned, and we are making our impact. We are also learning, not that we have gotten to the peak, no, we are still learning, but you can learn much from us. Subscribe to Jamal Engineering TV so you get all the details concerning our project. I told you. So the software will be pumping up for you to save your project after 10 minutes. The reason is, if you have a system that the battery is not strong and you are connected directly to the power source, once the light is taken, we're on the second floor now. I've copied, edit the same beam, the height and the load. Okay, we're dropping on the second beam, second floor. So and paste all the wall beam on the load. And on the 3D, that is why the 3D is very, very important. Remember what we were taught. This is how it is. All right, this is how it is. Once you drop them, they load, you see that the whole place is covered up. So you don't have anything. When we now come to the roof level, you can see that the staircase is still opening. So in this case, we'll still go back and then close up the staircase, because at that level it has become the roof, so it won't be opening again. This is what you have. This is what I'm saying. All right. In a good details work, what you normally need to do is that you can as well give your opening in each of these floor. The first floor, you can give all your windows opening. All right. You can give all your window opening. If you want to open the window, for example, 1, 2, what is the height? Let's say 1, 4, 5. Hmm? I told you these are uh, reasons why each each person choose a different software for their design. Don't forget, there is one thing we need to know in structural design, structural analysis. What I'm doing now is modeling. All right, modeling, as I told you before, go back to the video I first posted on Jamal Engineering TV. I've showed us, I've discussed with us what's the difference between modeling, what's the difference between analysis. You have modeling first. Before you can even talk of any analysis, you have to model according to the architectural drawing. All right, you model. This is what we have done. This one is just modeling. Now, it is after you have done the modeling, that is, you have positioned your columns, position your beams, and then you can now go to the analysis. When you move from analysis, then you go to your design. From your design, you now go to detailing. Four: modeling, analysis, designs, and detailing. And all of those four will not be useful for the clients, are only good for professional, but it's not useful to the client until you do a detailing. It's when you have presented it on the AutoCAD that the client will appreciate actually what you have done. But what I'm trying to say in the other, I'm not just doing video. Okay, I'm not just doing videos, so that you don't just watch video without having understanding. That's what I'm explaining. In this case, you can see that we have not touched our foundation. In the modeling, you have to finish modeling, finish analysis, run your building before you now go to foundation design. Okay, because in the structural design, what we were told and what is in the practice is that you start your design from the roof level, come to the second floor, come to the first floor, come to the ground floor, then the foundation is the last place you design. Because the load is being transferred from the roof all the way to the foundation. So you cannot design foundation before you get to the roof. You come from the roof and the load transfer to the foundation, then you can now go to foundation and design. That is why you can see for now, it's like if the foundation is silent. Okay? All right, so we are here now. Quickly, we can now run our analysis. Go to run. What have we not done? Okay, let's set our material, please. Very, very important. Let's set our material. From here, we have done this. Load combination is good. All right. So let's look at pre-analysis. Before you do the analysis, please set your material. In this case, we are using, in fact, I've done the, after the projects, this, what do we call the carcass? We have all the contractor brought out the tests, the concrete cube tests that we have, and we confirm that some of the grade are even more than 25 strength of concrete, 28, 30, 32 we have. So we use grade 20 to grade 25 of concrete, apply to all the element, the structural element. All you can see now, it has showed from column, walls, and everything. Now we use the grade of steel 410. You apply to all too. You can see it has changed. Go to columns, select your, what are the column reinforcement? Y16, Y20. You don't have Y25. It's just too suspended. We don't have shear wall. So then we have beam. What are the reinforcement for the beam? Y16 and Y20. It's fine. We don't have Y25. We don't have Y12 for the beams. I told you we have standard in Abuja. Subscribe to Jamal Engineering TV. Then slab. We have Y12. I don't want to select Y10. That will complicate the issue. But we can use Y10 for the top, what we call the mat. That is for the shear force on the top of the beam. We don't have a rib slab, so you can leave it. Foundation, we use Y16 for the foundation. You can as well use Y12, but what we is something we have already done is Y16 that we use. So leave it that way. Then link, that is for your stirrup, use Y10. Uncheck all the other one. So this is what we have. Can now okay it. When you okay it, what why is it important is because if, for example, I pick my strip, I run. In this case that I'm running now, what it means is that this is slab strips, and it's important so that you can see, you can see this is 13 Y12 at spacing of 25, 250. All right. As well, I can delete everything. Why? Don't worry. Delete. Okay. So setting, we have done the general setting, you can come to your column setting. How do you want your column to look like? The steel bar. What method are you using? All right. You can set all your columns. Let's save it. Setting. Our stirrup is 200. You can use 225. Leave it at 200. We don't have war, but leave it at 250. Detailing. Okay. Go back to setting again. You go to your beam, story beam. You don't have foundation beam. So you can set all the things you want to set. The minimum is 16, the maximum is 20. That is what it's showing you. The link, the minimum is 10, and the maximum is also 10. Our beam is also 200 link spacing. So I'm giving you the details of everything you need. All right. So um, subscribe to our YouTube channel. These scales show you how it's going to be showing when you are exporting to AutoCAD. All right. Beam section, beam. Okay. Uncheck this. This is what I like. But in most cases, this is fine. But I use this most of the time for everyone on site to understand. That is what I do. Okay. There are a lot you can do about the setting. Just save, go to your slab, set all your limits for the spacing. This is where we have 20 mm steel. Our minimum is 100, our maximum is 200. As I remove all the strip that I dropped there before so that we can have 200. Concrete cover, yes. You can now go back to your foundation setting. You do all this before you go for your running because this determines what will come out at the end of the day. I'm taking my time here now so that next video I won't have this time. Maximum steel bar spacing for foundation. Let's say 200. 250 is fine. 250 is fine. Our concrete cover for foundation should not be less than 40. So you have 40 there, which is fine. You can as well change it to 50. So your biscuit cover, what we call the concrete cover on site, can work fine. So this is what we have. We have done that. Though you can now go back to your run. Whether you drop strip or not is when you are looking for to confirm. For example, let me show you a slab strip. This is what I want to show you now. If the setting is safe, it means that at this time now, you can see that time we first drop, you see that the strip show us 25. That is 250 because we did not set. But now that we have set it, you have each of the panel slab reinforcement details is showing Y12 as the spacing of 200 both top and bottom. That is what it means. And that is what the design specifier. All right. So you can close it. We don't actually need it. So we can just do it so that you have the understanding. If you want, you can as well save as many times you want before the software pump off. Run. You go to your run, click building analysis. Pre-analysis will show model option. We don't need it for now. Analysis, that is what we need now. Then post-analysis is what when you are designing. So you click columns and beam, reselect bar. No, we don't need that. Just click start the design. Start the design. Any questions, you can drop it on our YouTube comment section. You can reach out to us, subscribe to Jamal Engineering so you have details, more details of this project and other. Also, watch the video I did on the RAF foundation. The RAF foundation, we have the RAF beam, the RAF slab, and the building. We are on the first floor now. If you watch some of those videos, you have a lot to learn from the projects going on in Abuja, in Gusape area. It's very, very important to learn that RAF foundation. Many people don't know the design of RAF. That will give you also opportunity and edge over other contemporary engineer. Subscribe to our channel and recommend it for people too. All right, so the analysis are completed. Okay, now we can now see the section of our columns. How does it look like, and our beams. So you go to post analysis, you can see all our columns are passed. All right, all our columns are passed. But remember what I told you, all the ground floor columns. You can come to this filter column list under the column details, under the column design. This we have done with the modeling. We have done with the analysis now. What we are doing now, analysis are okay, meaning analysis are passed. What we need to do now, you go to design. The design means that each of the columns that are supposed to be Y20 or beams that are supposed to be Y16 this and that, how many top bar, how many bottom bars. This is the design. On these columns, you can filter, go to story 1. You click for filter by story. You click story 1. All the column here are supposed to be either 6Y16 or 4Y20. This is what I'm saying. So you click here because it's two suspended floor, and the recommendation, the standard in Abuja is that you must have 4Y20 or 6Y16. You okay it. All right, we have changed that already. So you okay it, you see it there. That is how all is supposed to be. You can go to second floor and see what is happening on the second floor and go to the last floor. All right, that is that carry to the roof. This is what you have. Any question? I have not gotten to how to present your design, the reports, calculation sheet, all of that are available. We'll do that in a subsequent video. So go to BIM. You can see all our BIM also pass. You can as well go to filter and go story by story. So filter by story, go to story 1. What are your beams supposed to look like? All the beams here are now on the first floor. So this is how it looks like. All right. Two, all that. And you can see all your spacing is 200 because we have done the setting. If you now want to check something on AutoCAD, you can now export from here, detail. When you click here, the drawing will go to AutoCAD for you to copy. So you can now, okay. All right. So the calculation sheet are also available here. You can close it because that's what you need. Look at it. Why this is because I've selected this beam and this beam. That is what I've touched that beam. That's how this one is. All right. Don't need to load the last floor. Now, what do we do now? We can now go back to our foundation. Go back to our foundation. In this case, the foundation here is purely pad. I'll just take 2, 3. I won't do everything. It's pad because the soil looks good. The footing depth, there are also recommendations like when you have the size of the pad determine the depth of that pad. All right. So you can see the soil test here, 168. Our bar for the foundation is 1616. So you see the depth 4. Let's leave it and check. It's 2 by 1 2. This 2 by 1 2, meaning that the depth can as well be 300. Can you see? The spacing is 250. Did it pass? All of them pass. Okay, 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 okay. If, for example, I go below, let's say 150, you can see it failed. I'm just trying to show you something. If you go 250, it may pass. You see? But since it's 1 2, the minimum should be 300 depths. So you can okay. Let's pick this one. It's also okay. You can click it. But in this case, you can see it's 16 by 16. It's no longer 12 by 12. So this one is 400 depth. Let's check this too. It's 1/8. So that 1/8 means this particular one cannot be 300. You can see it failed. When you use 300, it failed. That is the recommendation, is that once you have 1/6 to 1/8, it should be 400 to 450 to 500. All right. So let's use 400 plus 1/8, 400. It passed. It's fine. It's 19 by 19. I still remember vividly how we did them on site. So let's pick this one. It's 17 by 17. So 400 is still fine. You okay? So if you are checking your 3D, this is what is. Can you now see? So you can as well run all of them this way. All right. So for any further detail, you can ask us question, drop your comment, ask your question. This is Jamal Engineering Limited, Jamal Engineering TV. You can rotate your structure the way you want it. You can rotate it the way you want. All right. So this is what we have achieved today. After this, you can export all this to your AutoCAD and then go to your detailing. So for the design, this is sample of what the designs look like.